In fact, there's one over there.
You got it on?
Okay, can everybody hear me? Okay, so Jalen, Michaela, welcome to class. Make sure I do our attendance. We're going to jump into today's assignment. It's in Everify, so I'm going to put that information in there first. So we got Jamaria here. So you go to EDSB. We got to do our norms. So hold on. Before we do that, let me jump into this. All right. So Michaela, can you read the norms for us?
Respect the parents and others, respect the first class from the right sensitive and control and purposes that I feel like taking my teachers. We are here to public and also support secondary endeavors.
Okay, so you probably did all that for nothing. She said, huh? I think we did all that for nothing. Let me look up your schedule. What class you're supposed to be in right now. So you don't have a second period. You know that, right? You had me first period. So did you talk to Ortiz about that? Okay. We're doing, you're going to do something different. So you just hold fast. I'm gonna get you started on what you should have started on. Okay. And then I'm going to call Ortiz and see what's up. Because I don't know. You all have to talk. You got period 1 and then period 4. So I don't know. But give me a second. Go to your first period in SB and see if you can get the Everfile link because I got to register you for that class. All right. And I'll walk you through it on your screen in a moment. But let me get them started. So we did our norms. Townhouse GGI, that's every day. We are going to be doing it from 11:15 to 11:45. This is daily. There's also an opportunity to get 5 to 10 points for just participating. So try to log in at that time. You get the link from me. You get it on EDSB because I post it daily, or any of the teachers. Raspberry Pi kits, you see already we're going to be utilizing them for the remainder of the quarter and probably throughout summer school. This is mostly an initiative to get you guys in the hands in the framework of being engineers, computer scientists, or even just scientists generally. So look, you're going to have to use it because there's certain measurement devices, certain calculating devices that are only on the kit. They're not necessarily on your computer. So if you haven't gotten one already, schedule come to the school and get one. Usually in the building on Thursdays and Fridays, where I can help you set it up. Alternatively, if you damaged your kit and you need some assistance getting it back going, bring up your parts to the kit you have, and I'll try to get you another kit to get you going. Right? So do so as soon as you can. Can I get Tyshawn? You just got here. Can you read that screen there, sir?
And get extra credit for some of your classes. So academic effect on the coding job market. Why learn to code? Surviving private set code. Interested. Join by clicking and focus. Best code.
Thank you, sir. All right. Next would be Jalen Stuckey. Can you read this screen here, sir?
Daily test. Student will be able to complete the variation in SB. Hello, all three systems to one class. South SB from answers all pre-recorded videos each class. These videos are known, ready to read by 4 p.m. daily.
That's what you want the physics, right? So next one would be physics. And Micaiah, can you read this one?
Students will be able to achieve certification of future goals, math, Module 4, the SHOT via the Edify Online courseware. Classroom term today is conservation of energy. Word today is irreverence.
Yes, ma'am. You got it. Okay, so we're going to go into what we have to do. You need to download this link, which is your exit slip. And the exit slip is composed of just these values: your full name, date, class name, and period. And this period is physics with algebra, period 2. You have to define the classroom term. You can't just put the word in there. So that was conservation of energy. You have to also define the word of the day, which is irreverence, the definition in full form. Look it up on Google. And the objective I gave you a moment ago. Let me grab the information and put it in the chat so you can have it ready to use. And if you don't do anything else in this class right now, if I were you, it's the easy. When I was in high school, I got the easiest stuff out the way. So, before you start daydreaming or you drift off, try to get this done first. So it's the exit slip. Everybody should click on that to get started on it, including you, Jamari, so you can just have it ready to use for period 1. So that's a template above, just something to start you with. Now, again, to use it, you download it first, you open it up. Jamari, your kid, you're going to use something called LibreOffice to type into it. You don't have Word on there. So everybody has that link. Let's go through the assignment in EDSB so you know where to turn it in at. You'll turn in today's exit slip here. Now, every day we've been doing an exit slip, so your exit slip should match the days of the assignment. Grab this, put this in the chat, and do that. Jamari, you might want to change your EDSB, log in to EDSB over there, and log in under first period computer science so I can get you started. Your password should be Bulldogs with a capital B 2021.
Hey, Mr. Tyler, I got some questions.
You got a question?
Yeah, Mr.
Go ahead and ask your question because I'm about to have you read in a second.
I was trying to ask about I don't know what lesson I'm on. Like, they don't tell me what lesson I'm on. So,
What lessons did you finish though?
in the second one, but I can't tell.
I can tell you in a second. Give me a moment. Okay, so from the looks of it, let's see here. We got Carson. Where's his name at? Jamaria, you're in there. That's good. But you're in Keys to the Future. You're in the wrong one, Jamaria. But it's okay. I'm gonna fix it in a minute because you're using a different code. But you tried. Carson. Where's his name at? Yes, but if you go to computer science, there's a different registration code. I think you put the registration code in for this class. Remember, I told you, and there's Carson. So Carson, you only did lesson 2. You still need to complete lesson 1, 3, and today we're on 4. So if I were you, I would start on lesson 4 with this, okay? Now, you say what, Carson? Jamar, what would you say? Let me check your screen. Everybody else should be getting ready to start that software. Can I have Mr. Carson for points? Can you read what's in the chat from hello all the way down? Okay, so you see this right here, Jamar?
Hello and good morning. To all physics with algebra students, we will begin utilizing the Verify Future Codes Math online software. Please follow the instructions below. Your coursework is labeled as Physics with Algebra Q4 via this Verify website, and if you do not have an account already, you will need to register as a new student to gain access.
Log in,
Website
Mark.
website for Verify to log in and begin completing the coursework online is you will be required to take your time and pay attention to the instructions of each module and 80% or higher of the overall score towards full certification for this course. If your score is less than 80%, you will be required to retake the module until the appropriate score is achieved. Take care out there.
Great job. I'm trying to help out Miss Jones at the same time. You talking about the password for Everify? I don't know what you've set it for. That's something you did personally. If you don't remember what it is, you can go to forgot password too. Okay, because I saw your account, so only you set that up. So I'm gonna come out of this, and you let me know if you have troubles. The next big thing is everybody should click on the Everify link, and depending upon your course, you should be in Future Goals Math, right? So if we go here, come out of this, courses. So come down to Future Goals Math, review course, and let's get started.
Hi students, my name is Jamal Maris. I'm a 2013 community liaison for the Chicago Blackhawks, and I'm here to tell you a little bit about the team.
The Blackhawks joined the league in 1926 and have since won 6 Stanley Cup championships,
including 3 the past 6 seasons. The Blackhawks work hard toward accomplishing their one goal. From eating healthy to putting extra time at the gym, the players' commitment and discipline helps them achieve their goal. Let me introduce you to a few of our star players. Jonathan Toews is the captain and leads the team by giving 100% each and every day. Marian Hossa is one of the best two-way players in the NHL, which means he plays a strong offensive and defensive game. Duncan Keith is one of the hardest workers off the ice, and it shows as he leads the team in minutes almost every night. Brent Seabrook is a big, powerful defenseman who always seems to come through in clutch situations. When the Blackhawks aren't on the road, they like to be involved in the community and teach kids like you more about the game they love. The Blackhawks Get Out and Learn program, or GOAL, introduces hockey to elementary schools by providing equipment and clinics during PE class.
The NHL at NHLPA's Hockey Scholar program brings hockey to the classroom with computer games focused on science, technology, engineering, and math skills.
We're excited for you to get started. You are now part of the Blackhawks team. Get ready to tackle the next 4 games with Toews and Keith as we begin Hockey Scholar.
Welcome. I'm so glad you're here. I'm the head coach, and my name is David Romero.
All right, everybody. So this is the point where you can skip the tutorial. And you don't know your email. So wait, which account did you use for Google Classroom, for Google Meet? Right, and you don't know how to do the password reset? Right, and I can take you to get your phone. Your phone is up front, right? All right, so 1 second, everybody. I gotta help Jamara get her phone and stuff. Everybody should be starting right here on number 4, the shot. Okay, I'll be right back. Come on, Jamar. Okay, so Calvin, you didn't get it. You told me you know this. I sent it to you. Did it come through? Get them in that room. Okay, everybody, let's go through some of this. So we're on the shot.
Forces are everywhere in hockey. Different forces are at work when players shoot, pass, skate, and even stand still. Forces cause objects, like a hockey puck, to move, stop, speed up, or slow down. Today, your team will be practicing control over their shots. You'll be observing the effect of 2 different forces during a shot: the force of the player's stick on the puck and the force of friction on the puck. Let's start by making some predictions about what these forces do.
Okay, golden opportunity for points. I'm gonna start with Calvin. Can you turn on your mic and read the first option, all selections, and then choose an answer? So you see what's on the screen? Okay, so you're just gonna turn on your mic, read the statement, all the selections, and then choose.
You call me Mr. Tyler?
Got it? Yeah, all you do is read. What's wrong? You don't feel like reading today? What the heck? What's up with y'all? Okay, so let me come to, I don't know. You? Okay, go ahead. I saw you do this. Go ahead, Jalen.
Every force has both
Get on in there.
magnitude and acceleration, magnitude and direction, speed and
Remember, you
direction,
got to do one for computer
speed and
science.
acceleration.
The registration code from there, Jamari.
I think it's speed and acceleration.
You just put her business all out there. Oh, so Jalen, I can't hear you. Did you read it? Can you do it again? I had the mic off. You turn your mic on, Jalen.
Every force has both magnitude and acceleration, magnitude and direction, speed and direction, and speed and acceleration.
And which answer you think it is?
Speed and acceleration.
Okay. What about you, Mike, here? Carson?
I think it's magnitude and direction.
Okay. And Mike here, what about you?
Speed and acceleration.
Okay. Michaela?
Magnitude and direction.
Oh, it's a split. Okay. All right, next one, I'm going to have Mr. Carson. I need you to read the statement, all the answers, and then choose one.
When there's no friction, a gliding puck will Speed up over time, keep gliding at the same speed. Slow down over time, come to a complete stop. Uh, I say slow down over time.
Okay. And everybody else, Michaela, Kennard, Calvin, Jalen, what do y'all think the answer is? He says slow down over time. Remember, there's 5 points to contribute to the discussion. You said what, Michaela?
I said the same thing.
Okay. How about you, Kennard and Carson and Jalen?
Slow down over time.
Okay. Carson, you agree?
Slow down over time.
Yeah, I said that.
Okay. Okay. My bad. That's my Kia. Calvin, where'd you go, man? That give keys to the future. You put that registration over there? You did last quarter. New quarter. Okay, so I just ain't nobody coming for you. It's all love. We trying to get you to graduate, girl. Come on. All right, so let's move on to the next one. Calvin, do you feel like reading or no? No, we don't talk to you. Let's go to who hasn't read yet. Let's do Michaela. Did you read already?
The name of the question is how fast the object moves when it is pushed, how far object moves. How fast the object moves when it is pushed, how far object moves when it is pushed, how long it takes to push or pull object, how hard the object is pushed or pulled. I think it's how fast the object moves when it's pushed.
Okay. Anybody else? Okay, so about you, Kanar, you agree with
How hard the object is pushed or pulled.
how hard it takes to push or pull? Okay. All right. Anybody else? Remember, responses are 5 points. You said what, Makia?
How far an object move?
How far it moves? Okay. All right. We're going to keep going. If there's nobody else that wants to chime in for 5 points, let's see here. We're just going to choose one. Try to think about these questions as we go through the software. Next one. How about, I don't know, Jalen?
If an object isn't moving, the forces acting on the object are not present, unbalanced, balanced, accelerated. No.
You said what? Which one do you think it is?
Not present.
Not present. Okay. And what about everyone else? Like Carson, what do you think about this? Kennard, Smith.
Balance.
You said that one? Or you said balanced?
Balance.
Balanced, okay. What about you?
If an object is moving, the force
Balance.
on the object are
And you say it's which one?
unbalanced.
Unbalanced? Which one?
Not present.
So you said not present? Okay. What about you, Carson? This is a tricky one.
I say balance.
Okay, okay. Last one, I'm gonna have my Kia do. Wow, she's turning up. Okay. There you go.
Using this image, which force has a greater magnitude? B. Force B.
We'll read all the answers first, my Kia, then choose.
Force A, Force B, Force A and B have the same magnitude, not enough information. Force B.
Force B? Okay. And does everybody agree with her or they have a different answer? So Jalen, what are you thinking? Same answer or no? Carson, Smith, you agree? Okay.
Yeah, I agree.
All right. What about you, Michaela?
B.
Okay. All right.
Nicely done. Each player will be trying to shoot the puck so it stops on a set target. Your goal is to correctly adjust the forces so that the puck stops at the right spot. First, let's go over some basic information about forces.
A force is simply a push or pull on an object. You see these pushes and pulls all the time during a hockey game. For example, when players receive a pass, they apply a force with their sticks to stop the puck. As players skate, they apply a force by pushing against the ice, and the ice surface applies a force upwards on their skates to move them forward. Every force is made up of two things: magnitude and direction. Magnitude is the strength of the force. A greater magnitude means that the push or pull of the force is stronger. You'll see the magnitude of a force shown with an arrow. The bigger the arrow, the greater the magnitude of the force. The arrows also show the direction of the force. For instance, this is an upward force on the puck. Two arrows pointing in opposite directions show forces being applied in opposite directions. One of the forces we'll work with today is called friction. Friction is a force that works against the movement of an object. In other words, friction slows down sliding objects and can hold non-moving objects in place. Watch this puck slide along a cement floor. As the puck slides, it slows down because friction is pulling against the direction the puck is moving. You can see the puck is moving to the right, and the friction force is pulling against it to the left. This is why the puck continues to slow down until it stops. To understand more about friction, let's look at two surfaces: a hockey rink and a cement floor. Which surface has more friction? If we pushed two hockey pucks with equal force across each surface, which puck do you think would slow down and stop first? That's right, the cement floor would slow down the puck faster. That's because the cement surface has a stronger frictional force. Now that you know the basics of force, let's help the players perfect their shots.
Okay, here we go. There'll probably be some exercises on how we do this real quick. Oh, it always does this to me. It's like it froze. Oh, yeah, click on it. Okay, so the instructions, I'm gonna read them for you and then just pay attention to what we're doing. All right, so instructions state, in this practice, you'll test how different forces affect a player's shot, and then you'll work through the 3 different levels to help the players hit their targets. Your experiment consists of levels 1 and 2, in which you can change either the force of the player's shot or the friction of the ice surface. Afterwards, you'll change both forces to see how they affect the player's shots. First, let's shoot on an ice surface with low friction. Adjust the force of the player's shot 1 notch to the right by clicking and dragging the slider. Remember, this is over here. You want the puck to reach the target zone. So if I drag this, it'll move it over, and then they say, all right, it's in the middle of weak between powerful. Then I'm gonna hit the puck or shoot puck. And you see he hits it, and that's to that destination. That's how you know where you want it to go, okay? So now they're saying, good job. Now let's try some shots on your own. Adjust the force to make the puck reach the target. So 3, 2, 1. And then I got to hurry up and look at where I want to go. So it's right here if you see my mouse. And I want to adjust it so I can get right about there. And the friction's pretty high. So what do? Well, I can shoot the puck and see if it works. And I didn't make it. So now I got to do something else, right? Probably adjust it a little more. Let's see if I can get it. Oh, fell short. So I got to do a little more, right? And if you look up here, you can see how much force you need in case you want to know in the future of how you're doing. So as far as friction, it's a 0.33 newtons. Force, and the friction is always negative. Force is going forward, like the force vectors I showed you, and it's 12 newtons. So I moved it up some more, close to powerful. I don't want to overshoot. So I'm gonna hit shoot puck, and I made it, okay? Good job, you censored the puck. So basically I needed 12 newtons of force to overcome the frictional force of 0.33 newtons. A distance of total 13.7 meters. This is up top that you can see. Okay, so another try. Now where they put it? They put it right here. So now I got to determine where I got to go. They're saying up here, you're starting with at least 6 newtons and the friction is the same, no distance. So let's hit the puck. And it didn't make it, right? So now I got to adjust again. And I went up by 1. Still not enough, right? So let's go here, right in the middle. And it took about what? 10 newtons for a distance of 9.5 meters. The friction did not change. Okay? So that's just things to think about. All right, last one. So it's right in front of me. Anybody in the class, should I change it or should I leave it the same? Let's see if we can guess at what the best way to do this is. So I'm going to start with, I don't know, Jalen. You're good at video games. Should I change it to some more force or should I leave it as is?
I think you should leave it like that.
And just shoot the puck?
Yeah.
Very good, Jalen. 10 points. Good choice. All right, so everybody got an idea of what you got to do, but you got to go through and understand more about force vectors. Okay? It's just as serious as it gets. So let's go here. It says if the player apply a larger force to the puck, it causes a larger charge in the puck's movement. The puck travel a long distance, right? So let's do this. This time we'll keep the force of the shot the same and adjust the friction of the ice. Remember I told you, when we're doing force vectors, friction is always opposing the applied force. That's exactly what drives something to move. If we actually go to 6th class grade America and we did some physics experiments, you would understand more about inertia. That is the force that goes against you when you're about to come over the side of that long roller coaster and make that dip. You'll feel a force upward and then you're dragged by gravity the rest of the way. Okay? Keep that in mind as you're dealing with friction. And friction is also what slows the roller coaster down or whenever you hit your brakes or you're on a bus. That's frictional force, and in some cases you feel inertia. Okay, so now it tells you can start by now changing your frictional values. So we're going to do that. So it says start by setting the friction to 0. So we come all the way down, right? Now it's no friction. That means even if you want to slow down, you can't because it's going to allow you to just keep on slipping on past. There's no friction. On flying past, as you see, there's nothing to slow it down. There's no friction, right? Imagine your hands together and you do it for enough minutes, your hands will get hot, right? That's called frictional force, thermodynamics in some cases. Now you try a shot. Adjust the frictional force to the target. All right. So first, it's going to count down. It's going to tell us what the target may be. All right. So it's right here. What do you think I'm going to do? I'm going to hit this. And is it going to make it? No, there's no frictional force at all. Remember that, right? It's nothing to slow it down. So I want to get it to that target for 10 points. Who can tell me what can I do in terms of my frictional force to make it stop at that target? So let's go to Kennard. Should I move the friction all the way up? Should I bring it up 1, 2? What do you think?
Bring it up.
Bring it up what? How many levels?
A notch.
1 notch, okay. And hit puck, shoot the puck?
Yeah.
Oh, not enough. So you want to take another stab at it?
No.
Said no. All right, Carson, what do you think? We went up by a notch. Do we go up 1 notch, 2 notch? What do we do to make it stop at that target, Mr. Carson?
2 more.
2 more. All right, so that's going to be 1 notch more, 2 notch more. So it's about here. And shoot the puck, sir. Think it's going to work? Okay, he didn't respond. Let's see if he's right. Oh, he fell short. All right, so the only reasonable option is full notch, and it should stop right at the target. Okay, so we're gonna stop here and review the objective. I want you to go all the way through this because this is lesson 4. This stuff is not hard. It's a little math involved because I think to some degree you're gonna understand F equals ma, which is Newton's second law. Force is equal to mass times the acceleration, and force can be applied force, which is positive, or frictional force, which slows things down. So let's go to our objective. All right, so I'm gonna change screens. All right, so can I get, let's see here, Mr. Carson, see you moving your camera around. You don't like being on the camera screen. You just like showing us the ceiling all the time. Can you read what's on the screen here?
Hey, Mr. Tyler.
Yes, you said what?
I said, did you call me?
Yes, I said, can you read what's on the screen?
Students will be able to achieve certification of Future Goals Math Module 4, a shot. They'll ever fight online coursework. Classroom term of the day is conversational energy. Of the day is irreverence?
Irreverence.
Irreverence.
There you go. All right. So don't forget, you have to fill out that exit slip portion. You put the term of the day, classroom term of the day, the word of the day, and also the objective into that exit slip. That's one of the things you should do as quickly as you can and try to get some of this done. All right. So it's 10:55. I'm going to set a clock for 10 minutes. You're going to go around the class and make sure everybody's on point and doing what they do. When I come, after 10 minutes, I'm going to go into Everfi and see if you've improved your scores. Okay. So you know which section we're on, number 4. Try to get as much done as possible. Hey, Alika.
Hey, Mr. Simon. What time is it?
So, Alika, do you have access to your Everfi Future Goals Math?
I'm Las
Huh?
Vegas at the moment. That's fine. My time different.
Alika, you got so much noise in your background. What did you say?
No.
Okay. So you never signed up for Everfi?
Matter of fact, I did, but I gotta go to it.
Yeah. So you see my screen?
Yeah.
We're doing this one. I'm gonna see what you started on. Burning. Yeah, Alika, you're in the software, but you haven't started on any of them. So
I,
you might. We're working on the shot today, and tomorrow 5 and 6 will be due. So you might want to get started on that. And you got the exit slip also. It's in the chat. I'll put it in the chat again. Do you need the link or what do you want to do? Because it's almost time
yeah,
for
you put
ER.
it.
Okay. So
Oh,
we'll
it
put the
is. I know
information.
my time different out here, so I was asking what the time is because it say it's 9 o'clock out here where I'm at.
Yeah, you got a time difference. You're not in Chicago time, right?
No, I'm in Las Vegas.
Yeah, right. So you got to get used to that. If I were you, I would do a Google Calculator converter so you can see. But I put the exit slip link in the chat. You can watch the video later and get caught up. But you need to get into that Everfi and finish that future goals math sections 1 through 6 so you can get your grades
Okay.
up. Okay.
Okay.
All right. So that's the information for Everfi and the link. Everybody, let's review the objective. We gotta get ready for townhouse. Let's see here. Alika, can you see my screen? Can you read that for us?
Students will be able to achieve certification of future goals math model for the shot video Everify online courseware.
Well,
Class time. Class time of the day is. You get me?
okay, here you go. Classroom term today was, you just stopped talking. Okay, so classroom term today was conservation of energy. Word of the day is irreverence, everybody. Jalen, can you read the townhouse information in the chat? All the way down to Zen. Jalen, you with me? There you go.
Challenge you guys mentioned for all students, life skill class of the awesome opportunity that students can take advantage of long today and get some extra credit for participating. See you there. Let's code is later on today.
Okay, so townhouse is in a few minutes. This class is over in 2 minutes. You know what you got to do. Don't forget to turn in your exit slip. I need everybody to click on the townhouse link, which is right there underneath the 11:15, 11:45. And I'll see you over there. Remember, if you participate, you get 5 to 10 points. So I'll see you all tomorrow. Try to get all this stuff turned in.